Well, good afternoon and welcome to Comp Comp 422 and 620. And we're talking about security policy models today. Of course, you can always look in the syllabus and the schedule and see what we're going to talk about and what you should be reading in the textbook. If you haven't read it, this is a material covering first part of chapter 5 and some of chapter 6 and a little bit of chapter 7. You notice there's only certain sections. And Monday, not Monday, Wednesday. Hey, don't be here Monday because Monday's Labor Day and there aren't any classes Monday. I'm not going to be here Monday, be sitting all alone. So no classes on Monday because it's Labor Day. Classes resume again on Wednesday. All right, if you remember from last time on Monday, we did talk about access control, talked about how to get from an unauthorized state that you couldn't write a perfect antivirus or system to check. It's undecidable. That subjects who own an object can grant privileges to others, but can never grant privileges greater than they have. And in Microsoft Windows, there are several levels, deny being the highest priority one, then full control. Full control gives you everything. And then there's write, which is read, write, and execute. Then there's read and execute, then just read, and then nothing. And that's it. You can put users into groups to make it easier to give access to a particular group. And of course, if there are users in group and somebody might be in multiple groups, and you have to combine the privileges to figure out what access they're going to have for like I just said, yes, you can combine multiple groups. Got to check it out. If we don't give any permission, then whatever other permissions that are out. By default, usually, if you have no access, then you'll have no access. I think I just mentioned the permission order, so I was way ahead of myself. Access control matrix, you saw this last time. Of course, capabilities are the rows where it specifies what an individual user can have. Usually, access rights are stored as access control lists, which are by individual object. And for each object, the system keeps track of who can access this thing, who has rights to access. And again, if you do it by groups, you can just say a large group of users have access to this thing. Today, we're going to talk about security policies. In particular, we're going to talk about the Bell-LaPadula model and the Biba model, two very popular security policies that are used. Okay, what is a security policy? Well, you want to define what is secure. Last time we talked about security in an abstract, formal sense, but you want to know what is secure for your system. What do you mean by being secure? And a security policy defines what you want, who can do what users can do certain activities, what users cannot do activities. So you have to define what you want users to be able to do and what you want them to not do. Why does it make a difference? Why is security policy important? Because no matter how secure your system is, if you go off and give the keys to everyone, it doesn't do you any good. You have to define a security policy and decide who gets to access these things, and then have the mechanisms to enforce that security policy. There are all sorts of security policies. Military or the government has a security policy, and we'll be talking a little bit about that one. And that's primarily for protecting confidentiality. Don't let people see things. This is a top secret document, and don't let people see it. There are commercial security policies, and those are primarily for integrity. Don't let people change this information. There's also confidentiality policy. People keep information confidential. There's certain information you shouldn't allow others to see. Otherwise, when you collect information, it's supposed to remain confidential. That would impose a confidentiality policy. And of course, there are integrity policies to make sure that you don't want people to change things. If you begin in a state that is secure or confidential or trustworthy, then if you move through certain states, allowing only certain activities, you can maintain your consistent state. Usually we perform what's called atomic actions. Atomic actions are often talked about in databases. You make atomic actions. An atomic action is either viewed as hasn't been done yet or is already complete. You never see an atomic action halfway through. The system only shows you either it hasn't started yet or it's done. You don't see inconsistency. You don't see it halfway done. Happens a lot in databases. If you're going to make a transaction, change something, other users only see that you haven't changed it or you have completed the change. You never see half the change out there. And then there's this question of trust. And we'll talk more about this this semester, but administrators have to have a trust, say, in patching an operating system or software. The administrator has to trust that the patch they got comes from the vendor and has been tampered with. If you have both Microsoft and Apple systems, every now and again, in fact, if you have an Apple system, yesterday was the second Tuesday of the month, and that is the day that Microsoft tends to roll out new changes for the month, and you'll get new changes that you, if they're installed in your system, you trust that they came from Microsoft and that nobody changed them before you installed them. You also trust that the vendor tested the patch thoroughly. Now, CrowdStrike changed that trust, violated that trust this summer when they sent a fix out for their software that screwed up millions of computers throughout the world. They had not tested it thoroughly. Vendors trust that the environment they have, local environment, you hope so, and you trust the patch installs correctly. Proper way to do patches from any software is to try them on a particular group. Often people try them on the group. If you have an IT group, the IT group will install the patches first and see if they caused any harm. And if not, then they will patch the rest of the organization. Because sometimes patches don't work. In a formal sense, okay. We hope that a given input for a program produces the output that you want. So we'll assume that some security program formally verifies something works with the operating system, provides trust. Okay, so formally state trust. First, you have to have a proof of trust. Yeah, and I in the theory class in computer science, students do proofs, and not all of them are correct, I might point out. So there are even bugs in automated proving theorems. You have preconditions. What is the first, and then what's going to be after you is executed. And you have to know what's there. And then what happens after a statement of code. Well, we hope we know it, but sometimes things don't work the way out. Sometimes, even though it looks like it ought to work, there are other parts of the system don't work. On rare occasions, there are compiler bugs. Libraries don't work the way they're expected to. Sometimes there are even hardware bugs. This, by the way, slides come from the textbook. The Pentium F00F bug was discovered back in 1997, but it turns out it was an Intel processor. At that time, it was Intel. Pentium was this machine, and there was a particular instruction that if you executed it, the machine stopped. Boop. And you had to reset. You had to press the reset button or power it off, power it back on before it would run again. That was, so even if you had your program that looks like it was just going to write this instruction, which is a very rare instruction, when somebody executed this instruction, that was it. Textbook offers this policy question. Imagine we're having policies. A university disallows cheating, which is defined to include copying from another student's homework with or without permission. I might note that the College of Engineering, Computer Science Department, has that in their cheating policy, that you can't copy another user's work. So now, computer science students are doing their homework in the computer lab. Say they're writing programs in the computer lab. Imagine it's Comp 163, Introductory to Computer Programming. They're writing programs in the lab. And one student saves the work on that lab computer, but doesn't protect it from other users seeing it. So Alice, of course, it's always Alice and Bob. Alice forgets to write, and Bob copies it. So the question here on policies, who cheated? Did Alice cheat? Did Bob cheat? Or did they both cheat? because in the computer science department, you are guilty of cheating if you allow another student to copy your work. Well, several ways to look at it. One way is Bob cheated. The policy forbids copying homework assignments. Bob did that. So the system entered an unauthorized state where Bob has a copy of Alice's homework. That's an unauthorized state. Therefore, the action that Bob took violates the policy and is cheating. Although policy does not say you can't use it if you find it on a lab computer, it does make sense that we allow something that the general policy prohibits. Another way to look at it, of course, is what about Alice? Did Alice cheat? Well, Alice didn't protect her homework. Although the policy doesn't necessarily say that you have to protect your work from being seen by other students. So she didn't really breach the security policy. She certainly didn't help the system. She didn't help Bob. Because if the policy had said students had to read protect their files, then Alice would have violated that policy. But she didn't do this. So Alice didn't violate the policy and Bob did. You have to write your policies carefully. And you can protect systems with policies and mechanisms. Policies state what you can and what you cannot do. Well, mechanisms enforce those policies. One of the mechanisms is you can make your files read protected so that if you put a file out there, others cannot read it. Again, that's access control of the file. You can prevent users from doing this by using the mechanisms provided by the operating system to keep people from reading your file. And other policies to keep people from bringing CDs or floppy disks into a computer facility to keep what's happening. So the mechanisms can be technical or procedural. The technical one, again, is where the system provides the ability to keep you from somebody else from reading the file. They provide passwords to keep you from allowing you to authenticate yourself, that only you can use it. Procedural is where you have policies that tell users they can't do things. Imagine you have a industrial situation, and you might have a policy that says users cannot bring software from the outside. And somebody brings in a disk containing a game that they got from an untrusted source. Almost all the games come from untrusted sources. Then the company might fire something or punish them in some mechanism if they violate the procedure. Controls can be mandatory or discretionary. Mandatory access controls are where there are control access to certain files that are required. The system enforces them and they're always there. You don't have the option of making them. Discretionary access controls, similar to what we talked about on Monday, is where you can say, well, I don't want Mary to access my file, but it's okay if Fred accesses my file. Those are discretionary access controls where the user has the option of specifying what controls they want, who is allowed to access. Mandatory access controls, you don't get to specify what you want, they always happen. There's a version of Linux, SE Linux or security enhanced Linux, that enforces mandatory access control using the Bell-LaPadula model, which we will talk about momentarily. Security enhanced Linux was created by the National Security Agency. They took an existing version of Linux and modified it so it has mandatory access control. The security enhanced Linux operates with default denial. That is, if you're not allowed to see something or do something, then you can't. So if you're not allowed access to a document, then you have no access to it. It's interesting to note that the Android operating system uses security enhanced Linux as its base. Android is built on top of Linux. In other words, they took the Linux operating system and added an interface to it. They changed the memory access things. Android doesn't use virtual memory, whereas standardly Linux does, but Android uses the virtual memory system for something else. But that's not this class. Take the operating system class, learn about that. Anyway, it does use security enhanced Linux, so it can provide security between apps. In Linux, on Android, the different apps are different users. Since there's only one user on your phone, the different apps take the place of like users in a regular Linux system. The original Linux system, of course, based on Unix, was for a system that had lots of different users, and security was by users. On Android app, security is by the different apps. Different apps have different access to, and they can talk to others or do something others only based on the security that the system gives them. And it's all based on the Bell-LaPadula model. Okay, the Bell-LaPadula model. It's a state machine model, and it forces control, and it's used a lot in government and military applications. It was developed, of course, by Bell and LaPadula. Who else? Of course it was. And way back in 1973. So what is that? Boy, that's been 50 years ago. I was there. But yeah, it's been around for a long time, and it's a mandatory access control. And it's a confidentiality policy. Okay, let's talk about that so you understand how that works. And just to let you know, there's all sorts of interesting questions I can write for Bell-LaPadula models. And so I like to use questions like this in the test. It's a hint. All right, we'll talk about it in 2 steps, because you can talk about first simplified version and then enhance it. So step 1 is the simplified Bell-LaPadula model. First, things have security levels. You may have heard of these, top secret, and then there's secret, confidential, and then unclassified. And obviously, top secret is the highest, unclassified is the lowest. And both people and objects have security levels. Objects, typically files, documents, those sort of things, have security levels, and then people have security levels. Also, subjects, you might have programs, I think, could have a security level. All right. Whole basis is you can read down and write up. So read downs are allowed, but you cannot write up. In other words, if you're a user at a particular security level, you can read things at that level or lower levels. You cannot read things at a higher level. So if you have a confidential security rating, you can read anything that's at the confidential level, but you cannot read any document that's at secret or top secret level. So formally, a subject S can read object O if and only if the level of the object is less than or equal to the level of the subject. And the S has a permission to read it. That's the discretionary control. So as far as the Bell-LaPadula model goes, a subject person can read an object or file if and only if the level of the object is less than or equal to the level of the subject. And that's generally referred to as the no reads up rule. Make sense? Very good on that one. Then there's writing. You can write up, but you cannot write down. So if you're a user at a particular security level, you can write documents at that security level, or even documents at a higher security level. Seems weird, we'll talk about that. You cannot write down. Why can't you write down? Because if you have information at, say, the secret level, if you're writing something at the confidential level, you might write information that is secret. So by preventing you from writing objects at a lower level, you are ensuring that information doesn't leak. Now, this is a mandatory access control system to maintain confidentiality. And if you follow all the rules, information cannot leak to a lower level. So they call this the star property. I'm not sure why it calls it the star property, but the textbook does. Basically, a subject can write an object O if and only if the level of the object is greater than or equal to the level of the subject. It's the no writes down rule. Now, writing up might seem a little unusual, but it is possible for you to combine material at a given level and produce information that is of a higher security level. People have shown in the past that by Googling or searching the web and combining a lot of documents at one level, particularly at unclassified levels, suddenly you end up with a bunch of information that the government would not really like everyone to see. And so you could put that at a higher level. And yes, imagine you have a big data system that combs through great volumes of public information and discovers insights. Doing data mining, and it discovers insights that might be more secure than the information in itself. Okay, so you could, if you were combing through information at a confidential level, you might come across some information through data mining that needs to be recorded at a secret or top secret level. So, for example, we got a security level for we have some subjects. We'll imagine those subjects are there at those levels, and we have some objects that you might put at those levels. So, and in this example, Tanya, who's got the top secret, she can read everything because everything is below, and she could write things that at the top secret level with that set. Claire, who's at the confidential level, can read, cannot read the personal files because those are highlights. You can read activity logs, the telephone list. And Emoja, who's unclassified, he could read the telephone list, and that's it. He could also write the telephone list. Okay, good enough? Pretty simple. Let's make it more complicated then. Okay, but we'll first start with, if you start in a secure state, then every transition, if you follow these rules, you'll always remain in a secure state. If you think about the stuff we talked about on Monday, all states that the system can be in, you'll always be in a secure state if you follow these rules. And a mandatory access control requires you to follow the rules. All right, make enough sense? Then let's try our question on that. Now, let me get the online people going here. Okay, there's a question online. People can see it. We're using, I ran out of, using those clicker cards. Hopefully the strange pattern clicker cards I handed out. Hopefully you have them. If you don't, I ran out of them. I've ordered more. Amazon is not responding like it should. Usually on Amazon, you can say, yeah, I need it tomorrow.
I think our question is different from the one that's on the screen.
Excuse me? Whoa.
The question is different from the one that's on the slides.
Oh, thank you. Okay, hang on. Yeah. Sorry. All right. Oh, where is it there? Oh, there it is. Blackboard tends to reorder the questions for me. In fact, you'll notice the questions have a number by them. That's supposedly so I can get it in order, but you notice this one's 0. I started with 1. Right, computer scientist. I should know everything starts with 0. Okay, so there. Think about that one. All right, anybody got their clicker cards? Clicker cards, you gotta. Hey, unlock it. Oh, I'm happy to say I did look at the survey that everybody, and I had all sorts of slides for it, which I forgot, and I will bring the slides on Wednesday next week. But one of the things, everybody uses a password on their phone. Everyone. Some people use facial recognition too. Some people use fingerprints, but everybody has at least a password. Nobody has a phone with nothing. Happy to hear that. Oh, it can all be to the side. There we go. All right. Hold them up if you got them. Remember next time if you didn't. And I'll try to print some more on the paper. Okay, gotcha. All right. That's it. All right. Okay. With 88% of the people online, yes, the answer is A, top secret. This agent has to look at materials that are all different security levels. So if he's going to read material at least the top, someone at the top secret, he's going to have top secret access. All right. Okay, moving along. Maybe. There we go. All right. let's make the Bell-LaPadula model a little bit more secure and a little bit more complex. Okay, in addition to having levels, we'll also add categories. You might be allowed to see information in a particular category. All objects have a level in a category, and all people have levels in a category. Subject. So it's subjects, and so we have this relationship dominating, or the DOM relationship, and one user dominates an object if and only if. So again, okay, we'll just go two objects A and B. Level A, object A dominates will be if and only if level A's level is greater than the level of B or equal to, and the categories of B are a subset of A. So let's give some examples to clear this up. Note that this is a subset. You can't have anything in A that's not in B. Okay, so let's imagine we have something that's top secret, and it has the categories, let's say, nuclear and Asia. It will dominate an object that's secret and nuclear, because secret is less than top secret, and nuclear is a subset of nuke. Okay, subset of these. Okay, also, secret nuclear Europe dominates confidential, which also has nuclear in Europe, because, again, the levels and the nuke Europe are a subset of that. Not a proper subset, but a subset. Okay, now these don't. Top secret does not dominate confidential Europe, because Europe is not a subset of these, a subset of nuke. In other words, the user, or well, these don't necessarily say which one's a user and which one's an object, but in order to dominate it, the categories have to be a subset of this. So even though the levels, confidential Europe does not dominate top secret nuclear, because, well, for both reasons. This level is too high and the object is done. And again, top secret Europe does not dominate nuclear Europe, because while Europe is in here, nuke is not in here, and therefore it's not a subset. These are not a subset of that one. Make sense? Everybody got that? Okay. Security levels are partial ordering. You have to have those levels at the right level. And then you have to have the subsets. So, yeah, okay. Greater than is a total order, but it's a partial ordering. Okay, let's talk about this. Again, information flows up, not down. You can read down. You can read at the same level, and you can read down, but you can only read in your categories. You can't read things outside your categories. And it kind of makes sense. Somebody might have top secret access to nuclear weapons, but they don't need top secret access to the State Department. Whatever, I can't think of it. I'm trying to think of good examples, but yes. So you might not be able to read that out, even if you have top secret access. So again, you got to dominate, subject dominates an object, if and only if the level of that subject, and you've got it. There's no reads up. Same thing with writing. In writing, in order to write, the level of the object has to dominate the subject. Notice it's backwards. In order to read, the level of the subject has to dominate the object. In order to write, the level of the object has to dominate the subject. Got it? And of course, that dominate relationship was displayed. Okay. So again, if you start in a secure state and you follow the rules, which are, of course, mandatory rules, then you'll always remain in a secure state. All right, let's go through some examples. Let's try this one. Let's get those polls to work. This should be question. All right. That looks like the same question. Good deal. Okay. So Oh, okay, oh, during class, let's get that. Right. Yeah, pointing this way. Okay, thanks. Remember, don't figure it over. All right. Okay. Popular answer is C. Let's take a look at this. All right. Fred has the level secret and he wants, or top secret, and wants to read a document that's secret. Well, okay, that's it's got the level. You can read, you can be able to read that. Won't be able to write it because it's right down. But let's look at the that. Uh, hmm. Sorry, hang on. Weirdness. Okay. Yes. Is this what we're looking at? Yes. Okay. Oh, I'm sorry. I'm looking at the wrong. Secret. Okay. It's allowed to read this because that, but he can't write it because you can't write down. In other words, if Fred has got secret, he can't, it would be a write down to write at a confidential level. So even though the categories match fine, he can't do this. So the only thing he can do to read, the answer is read. Everybody see that? Why it should be read? Okay, can't write it because that'll be writing down. Fred is secret. You can't write to a lower level. You can read to a lower level, but you can write to a higher level, or of course the same level, but you can't read. All right, let's try again. Okay. Okay, where did that question go? Okay, scrolled off. You got an answer? You got to pull it up and look at it.
Yeah, that's exactly.
Oh, yeah, it would help to be the question. I mean, you got a good represent chance of being right anyway. Oh, and obviously, by the way, as you can tell, I don't know whose card this is. I don't know. Just getting it. You now you're voting now. All right. 77% of the online people, somebody out there is asleep, but and we'll share the results. Kind of mixed. A lot of people voted both. A bunch of people voted none. The answer is D, none. Let's look at that because Paul's top secret and wants to read a secret. Wants to well, he could read because but these objects B and C are not a subject. There's no B here. Paul isn't supposed to know about B, so he can't access that. So the answer is none. Paul can not write it, nor can he read it. Agree with that? Answer is none. You gotta use the dominates. That dominates is the levels have to be, in order to read it, you have to have the same or higher level in order to, but you have to have the categories that match. Okay, let's try another one. All right. Let me see if I can get the polls to work here. This. All right, got it. maybe. Oh, hang on. What is that? No, that's the wrong one back. What this is? Oh, okay. All right. Some days Zoom is not zooming for you. Okay. Oh, geez. Oh, okay, there, we have to vote. The app doesn't pick that up, but it's, I got it, okay. All right. Oh, okay. We seem to have come to consensus here. Almost everybody likes D, which is good because D is the answer. Yep, categories don't match. Even though the levels match, the categories match, don't match, no access. All right, try again. That's another one. All right, that worked. It's even the right one. Actually make multiple choice questions on the exam. You almost never see multiple choice questions like the holding open black. There you go. You hold over the symbol. It doesn't work. It can't figure it out. Okay, well, we have both groups have a difference of opinion. It's kind of split between A and B. We're pretty sure it's not C or B, C or D. Okay. The answer is A. All right. Susan's got top secrets. That's a higher level. So she can read down. She can't read up, but she can read down. So she can read confidential. The category A is a subset of A and C. So she can read that. A is in the subset of things that Susan can see. So she's allowed to see it. So she can read it. She can't write to it, though, because she can't write down. She only read down. Okay. Let's try one more, maybe. One more. Okay. Okay, got it. Oh, okay. Almost everybody thinks it's D, none, which is good answer because that is the correct answer. Joe is unclassified. That's the lowest level. Can't read anything higher than that. Doesn't work. All right. Okay. Let's get rid of this and move on. Now, oh, question, yes. One more time. Oh, there was a question that says, okay, you can read down, but you can write up. The question, well, why can't Joe write up to a confidential level? That's a good point. That might be, yeah, I kind of took it somebody's unclassified, can't do anything, but no. Category, what is the, now, of course, writing, if you write it, the object has to dominate the subject. And the levels certainly dominate it. B, yeah, I think that might be, yes, question. I'm sorry. Yes, this is how you could. Well, notice that Bill, oh, no, the document has category B and Joe has no categories, which you could think of as something like an empty set. Well, okay, let's go back to that confident, that dominating, this is where this is the key to all of it. This is the formal rule. And again, so we have Joe, who's level unclassified, and the categories are empty set, nothing. And he dominates the object. And well, okay. No, but can he write to it? So if you write to it, you want to write to an object, the object has to dominate the subject. So the object would be confidential, and that beats Joe. And the object's categories are B, no, the object categories are B, which is, okay, B is not a subject. Well, empty set. Is the empty set a subset of a set? Let me think about that and come back next week. Won't come back Monday because there's no class Monday. That's a good point. And the empty set is a tricky one. I don't know. I'll find out though. So yeah. You know, I've taught this class for several years. I use the same question. Nobody ever asked that. And that's a really good point. Let me think about that. All right. But I think that's a problem. There's another problem here with the Bell-LaPadula model. Okay, here's the example. We have a colonel who's secret, and then he's got the categories nuclear in Europe. And we have a major, because using military people, because this government uses this, major who's secret in Europe. So they got the same levels, but different categories. So the colonel can read a message from the major because the colonel dominates a message from the colonel. That would be secret. But for the major to read a message from the colonel can't write a message that's secret Europe. Has to. So colonel can't write at the levels. How can they communicate? The colonel can read a message, but the major can't read a message to the colonel. So the colonel, that's the problem. All right, everybody understand? It's kind of an issue there. You can send a message to somebody, but they can't reply. Okay, what you do is you make a temporary, yes, okay. You have temporary levels. You can have a temporary level where the object is going to be in. So, and of course, the current level, the maximum level has to dominate the current level. So you can give them a current level. So what it is that the kernel can operate as if they didn't have the nuclear, the temporary. And that level has to dominate the current level. Okay. So major treats the object kernel is right to him. Major is the maximum level. For the current level, kernel sets its current level to this. And now they can write the same level and communicate with each other. Okay. There is the principle of tranquility, which states that subjects and objects cannot change their security levels. Yeah, if you change your security levels, that makes it really not work very well. In the example with the major, then all they're really doing is dropping an area of security, not adding anything. So you can't raise an object's, once something's at a particular level, if you could raise it, obviously, but that doesn't do any good because somebody might have seen it at that level and it doesn't do any good. Yes.
application. Thing, someone wouldn't be able to write to the agent because
Yes, because the colonel has nuclear and he can't write something to the major because he knows nuclear and he can't release nuclear information. Right. Okay, so you go for a temporary, a current level. By the way, all this is in the textbook. I'm gonna have to read that textbook again to see what happens about empty sets. But okay, tranquility means you can't go around changing it. Raising a level's security, that doesn't do you much good because somebody might have seen it, and if you raise it, information might be out there at that level anyway. So it doesn't do anything. You could lower some things. So you can have strong tranquility and weak tranquility. Strong tranquility simply says you just don't do it. You don't ever change the classifications of an object. You don't change its level. You don't change its group. Weak tranquility says you don't change them in a way that you only change them in a way that doesn't violate the star property. And allows you to observe the least privilege. Okay. This only gets to be a problem with declassification. Declassification is when you're going to write down. In other words, you're going to take an object at one level and write it down to another level. Commonly what happens is the government might have something that's at a classified level and they want to let it out for everybody to see, so they have to declassify it. So they have to sanitize it. When they do that, there is an agency in the government that goes through the document and sanitizes that, they redact information that people shouldn't see and decide whether what's left over can be viewed by the general public. So somebody in authority has to say, we have to lower this, and then they go through and check and see how is this going to be done. It's been in the news. Yeah, the court case is bouncing around right now about former president's use of confidential documents. He had several boxes of classified documents, classified meaning secret, top secret, or classified, at Mar-a-Lago, and the FBI went in and raided his place, took the documents, and they are trying, government, the Department of Justice is trying to prosecute Mr. Trump for having declassified documents. Now, Mr. Trump says that he declassified the documents when he was the president, therefore he's allowed to have them. We'll see where that goes. If you've been following the news, about a month ago, the judge in the case said that the prosecutor didn't have the authority to bring this case, and the prosecutor from the Department of Justice say, oh, yes, I do, and they're going to take it up to a higher court and see, does the lower court have this, or does the prosecutor have this authority or not? Fortunately, this is not a law class, so we're not going to argue that one. Okay, so that's mandatory access control for confidentiality. There are also access controls for integrity. You can have integrity policies. Tell you what, before we go into the, no, we'll keep on going through this. Integrity policies. Integrity policies are more used by commercial organizations. Integrity policy makes sure that the information isn't changed. You can, you don't worry so much about people seeing the information as improperly changing the information. So a warehouse is an example where the employees may be able to view information, but you don't want them to change it. In other words, you can read up, but you can't write up. You can't change things because you don't have the authority to change. And so in general, integrity policies want to keep data from being changed by unauthorized can't talk to them. Can't prevent unauthorized people from changing the data. Prevents unauthorized data modifications from authorized people. In other words, people who are authorized can only change the data they're allowed to. It maintains consistency. Again, we want to have a system where if we start in a trustworthy state and we follow the rules, that will maintain a trustworthy state. There is the Biba integrity policy, developed in 1975 by Mr. Biba, of course. And it describes a set of states just like the Bell-LaPadula model, but instead of maintaining confidentiality, it maintains integrity. Okay. And it's kind of the opposite of the Bell-LaPadula model. And again, it's out there to maintain trust, that you can always trust the data has not been unauthorized modifications. All right. So in the Bell-LaPadula model, you could read down but not up. It's opposite here. You can, in this model, this is reviewing the Bell-LaPadula model here. We already know what that is. Going on, in the Biba model, you can read things at your level or a higher level, but you can't read things at a lower level. Likewise, you can write things at a lower level or the same level, but you can't write things at a higher level. So here's an interesting. We imagine a monk who's at, say, 3 levels here. We have top level, medium level, and low. A monk may be at the middle level, and they can write a prayer book that can be read by commoners who are at a lower level, but they can't write one that can be read by the high priest at a higher level. They may read a book written by the high priest, but they can't not read a pamphlet by the lower house. In other words, they can read at their level or read up. They can read something by the high priest at the higher level, but they can't read things from the lower level. They can write books to be written at the same level or at the lower level. Okay. So sometimes you have software you want to update it, you want to trust the updates. So the vendor generates patches at 3 levels. The vendor who generates IT administrators who oversee them, and lab managers install the patches. The vendor can send patches to the administrator and the managers, but they cannot send but the managers and the administrators cannot send changes to the vendor. Administrators can send patches to the lab manager, and the lab manager can install the patches they receive from the administrator. Okay, here's my example. Let's try it here. We have another Biba example. See if you can get this one. Again, we have commoners at the low level, priests at the middle level. No, the monks at the middle level, and the priests at the high level. Yes, and now we will start this online. And there it is. Okay. All right. Okay, got it. All right, that worked. All right, A is real quick. Okay, everybody likes A. This is a pretty simple one. Yeah, thank you. The Biba model is a little simpler than the Bell-LaPadula model. They can read up. So commoners can read a book by that because you can read up, you can't read down. So it's just the opposite of the Bell-LaPadula model, but there's no categories. So it's pretty simple. Okay. You might think about Biba categories. How would you do that? You wouldn't want to write to categories that you don't have, because then you'd be corrupting information. Can you read from categories you don't have? We're not terribly interested in keeping information confidential. We're trying to keep it trustworthy. So Biba doesn't have categories, but you might think about how you might add categories to that. Again, you have to remember it's integrity, not confidentiality. Availability policy, since we talked about confidentiality, integrity, the other letter of the CIA is availability, and availability policies for state when will the data be available, and if it becomes unavailable, how long will it take to make it available again? You might have a policy that says, well, we hope that our system was a goal. Usually you have availability goals, I would think, more than availability policies. long ago and far away, I was the manager of systems programming, and we had a goal of keeping the system running and having only one failure a week. And some days we could make it, and some weeks were not good weeks. So, and then you might say, well, if it goes down, how long is it going to take to come back up? All right, those are your, don't run away because I've got some more slides here. Textbook reading against, this is the material, and that's not Monday. Don't read that. We can read that, but it won't be Monday because Monday's Labor Day, and we don't have classes. There are no classes on Monday. It's Wednesday. I was thinking about Monday, but no class on Monday. Don't come to class. I won't be here. Everybody has all classes off on Monday. Go out and celebrate as you should on Labor Day. So, hang on. We'll move. I got some more slides to show. Oh. Okay. All right. Hopefully you can see this. Everybody can see the good computing practices. All right. We're having an assignment coming up. Stay tuned. Watch Blackboard. Something will be posted shortly. As soon as I get it ready. We will be having an assignment up possibly over the weekend, but it won't be due. It won't be due until a week after. But it will require you to install software on your system. And some people need to be reminded of how you ought to use your computer, how the computers work. File directories. There are a lot of users I know out there who, whenever they want to find a file, don't bother to go down the directory structure. They search for it. And that works sometimes, particularly if you can't remember where did I put that. But there is a structure for the files that file directory. You have the root, which is generally represented by a slash. Which direction the slash goes depends on whether it's Windows or Unix or Linux. Heaven only knows why Microsoft changed the direction of the slash. It's a terrible mistake, but they did it. Anyway, then you might have username. So, and then under that, you might have several directions. You might username, you might have pictures, documents, other music, other things. Say other documents. You might have directories. You might have directory for English, Comp 422, Comp 620. And under that Comp 620, you might have files. So you have files in directories, directories inside other directories, and those directories and other directories until you get this. The thing is, you can always go down the directories and find it, and that's, you don't have to search for it. This is important because sometimes when you want to open a file, you have to say where it is. You got to go down the directory structure, say, I want it, this file. So know how the directories are. And there's a file manager program in both Windows and Apple Mac OS that shows you all your files in the directory structure. All right. Okay. On Microsoft, doesn't apply to Apple, but Microsoft has a system called OneDrive. You may have seen it out there. OneDrive is a cloud storage system. It's a mechanism for you to store your files out in the cloud. Microsoft likes that idea, and they want to store things out of the cloud. They give you a certain amount of cloud storage that you'll give you for free. After you run out of the free stuff, they'll gladly sell you more storage. So now if you have a laptop with, terabyte drive in it, you're not using it if you're storing everything out on OneDrive, and when you run out of OneDrive, so if you keep things on your own computer, you won't have that problem. Of course, if you use multiple computers, OneDrive allows you to see your files in multiple places. Of course, do you have more than one computers? And you put it up to OneDrive, even though we all are supposed to trust Microsoft, who is looking at my data? You need network access to access the files that are not cached. Now, a nice advantage is if you have your files in OneDrive, Microsoft will back them up for you. Of course, that is if you are a Microsoft 365 subscriber. And if they have a hardware failure, gotta think about hardware failures. Definitely, you should always back up your data. We'll talk about that later on, but back up your information. That's important. Okay, so do whatever you want with OneDrive. Just know that how that works. Zip files. Generally, when you get a zip file, most of the systems allow you to see what's in it, but you can't really do anything with it. If you have a file that is zipped and it has executables, you can't run the executable in a zip file. You have to unzip, you have to extract it. That works okay, but Apple and Windows systems allow you to simply extract a file. On the Windows systems, if you're in the file manager system, you right click on the file, opens up a menu of things you can do. One of them is extract all. You get this dialog box here, and it tells you where should the operating system put the files when you extract them, and then you press the button extract, and it extracts them all. And if you click the little button, it opens up that directory. You can see all the files you have. Very similar system in Apple systems. There's also a program that works on Microsoft Windows called WinZip. It's a pretty popular utility, although you have to pay for it. WinZip will open up zip files also. It has a lot more options than by default you get from Windows, but that's why they sell it. Okay, this is a security suggestion for people in Microsoft Windows. In Microsoft Windows, by default, they do not show file extensions and extensions that are common. TXT, DLC, EXE are very common extensions, and they don't show them. Change that. Change it so you do always see the extensions, because it's been shown that malicious people can send you a file that's nicefile.txt.exe. Goes, oh, exe is a common extension, so I'll hide that, and it just shows nicefile.txt, which looks perfectly safe to you because, of course, it's a text file. Text files don't have any viruses because they don't have any executes in them. You can always open them up safely. But if you double-click on this, you're going to execute that program, and that is not safe. So if you're in the Windows world and you go up to View, go down to Show, go over to Show, click on file name extensions, and click the box, do the click box that says show file name extensions, so that you always show file name extensions. So you can't get fooled by that one. I don't know how that works in the Apple world. Somebody in the Apple world can send me an email and tell me about that, please. Okay. Paths. The operating system keeps a variable called path. And path is just a list of directories separated by semicolons that specifies where it's going to look. If you type in some program like prog, and it goes, well, where is this program? How does it find it? It looks through the directories that are specified in the path, in the order in which they appear in the path. So if you're in Windows, or if you are in Apple and you type path in the command mode or in a terminal mode, and you'll get something that looks like this. Copy that from my path. It goes path. There's a list of directories. You can see the first place I'm going to look is in this is the Java JDK bin directory. So, and then others. The order is important. If you have two executable files with the same name, it will always execute the one that comes first in the path. Typically, you put your operating system stuff up first, unless there are names of programs in some other application that you want to override the system ones, and then you put them first. Be careful about doing it. Oh, look, silence your phone. Don't let that happen. Sorry. Okay. All right. So that's paths. And again, now, in the Apple world, the Windows world, the Linux world, you always have this path command, and then you can change the path. You can go path, space, and specify what's there. On the Windows world, you can also go, if you go to settings, system, advanced system settings, you'll get, and then click on environmental variables, which is kind of the lower right-hand corner. You'll see this dialog box here. This dialog box tells you what local settings. You have local system variables and system variables. Local ones only related to you, and system ones related to everybody. That's in case you have multiple people using your computer. they won't see yours, but everybody sees the system ones. And since most people, I mean, I'm the only one who uses this laptop, so it doesn't make any difference. So it will merge them together. So there's a path up here for user is going to merge that in with this. So if you click on edit, it now gives you a nice feature. It's Windows 10. It gives you a nice feature to edit them. You can change the order. You can go up and down because remember the order is important. It's going to take the first one you find. You can remove them. You can add them. You change the list. Okay. So that's, again, setting the path. And that's important because sometimes when you add new software, if you expect it, if you download the Acme system and you copy it to you and you want to use a type Acme, it probably won't find it unless you put it in the path. Alternatively, though, you can put the full name. If you put it in documents /comp620/Acme's, you can put that directory name in front of the path when you execute it, and then it will find it. But you has to know where to find it. Either you have to specify it, the directory when you want to execute it, or put it in your path so it knows where to look. One of those two, or it's not going to find it. This set of slides has my test taking tips, which normally I show just before a test, but I'll tell you right now, and I'll remind you again, which is, somebody asked me about the type of tests I have. I generally try not to have tests that ask you to tell me what I told you. That's good for elementary school, but I don't do that. We're not in elementary school. So my tests generally try to ask you questions about trying to do something with the knowledge you've learned in the test. So I told you about the dominate. I'll ask you how to use that. You can bet there will be some multiple choice questions asking what level of access does this user have in the situation. I like it because I can have Blackboard grade them automatically. It's like that. And TAs like that. Okay. Study in small groups. Again, it's always good to study with a buddy and work on things together. Remember, you're supposed to study. Keep the beer in the fridge until you're done studying. Avoid all-nighters. You need to be at your very mental best for an exam. If you stay up all night, you will not be your mental best. Okay, when you're going through a test, go down at the questions. Assuming not this silly thing in Blackboard where you can't back up or something, but paper test or go through all the questions. If you know the answer, answer it. If you're not quite sure about the answer or it's complicated, go on to the next question because most tests have a time limit and you want to make sure you get the ones you can do right away. Don't waste your time on questions you might never answer correctly and then skip questions that you know. So if you know it, answer it. Then when you're done doing all the questions that you know, go back and work on the harder ones. Always read the whole question. Let me tell you, how many times I've graded things and students didn't read the whole questions. And there's like 2 parts to it. And they do part A, but they don't do part B. Read it. I can tell you, answers to the questions came from the stuff we do in class. If I didn't mention it in lecture, it will not be on the exam. I'm not going to throw things out there that wasn't in class. So if you think, so if ChatGPT gives you an answer that doesn't look like we talked about that, it's probably not correct. Multiple choice questions. Again, rarely am I, but the first one will have. Never leave them blank. Some systems are going to score you the right minus 25% of the number wrong or something like that. I'm not going to do that. It's just the number right. So never, guess. If you don't know the answer, well, guess. If it's 4 possible answers, you have a 25% chance of getting it right, which is better than the 0% you have if you don't put anything there. So guess. And stay in motion. Don't freeze up. Keep going. If you can't do something, go on to another question. Don't stop and really consider a question long and hard until there's no other questions to solve. Yes, sir. Depends on how long the exam is and how much time you have. I usually say if it's an hour exam and you have 10 questions, then you have 6 minutes per question. If you answer some questions really quick and you saved up some time, you can go a little farther. Now, in this class, you have 18 hours to do the exam. say there's 8 questions, you can do the arithmetic. That's 2 hours in each question. No, but it won't take you 18 hours to do it. Normally it takes about 2 hours. Do not start the exam at 11 o'clock at night because it's going to throw you out at midnight. So give yourself some time. But again, you ready? And I believe you can stop and come back. Okay, did somebody else have another question? Nope, okay, then that's it for today. That's all. No class on Monday because that's Labor Day. Go out and celebrate the fruits of your labors. Okay. Any questions online? Then adios. See you Wednesday.